Uh, Good morning, everyone. I am Tharathip Kulchotirat, Master degree of Science in Implant Dentistry, Mahidol University. Today, I am going to present the research topic, the effect of inter-implant distance on the angular area of implant scan abutments generated by intraoral scanners. This research project is supervised by Associate Professor Dr. Shuchai Anandmana. Now, the intraoral scanner is one of the devices that imitates oral cavity, just like a conventional oral impression. So the accuracy of the intraoral scanner is very important to provide the accuracy of the scan model or the oral cavity model. In implant dentistry, Kim and colleagues reported that the movement of the implant, maximal movement of the implant of 50 microns of the osseointegrated implant can lead to the prosthetic misfit. It means that if the prosthesis part of the implant make 50 micron movement of the osseointegrated implant, it can consider it as the misfit. So Andreessen and colleagues reported that 100 micron of two implants can consider it as the prosthesis misfit over the implant complex. And also in the same study, it was approximately 0.19 degrees that can make 50 micron movement of the osseointegrated implant. So two implants, it was approximately 0.4 degrees. But however, Busayan and colleagues reported that the range of the misfits is considered as between 22 to 100 micron movement of the osseointegrated implant. This depends on the density of the bone that osseointegrated implant placed. So what are the factors that affect the accuracy of intraoral scanners? It was a lot of factors that affect the accuracy of intraoral scanner. One of those are size of the induced area. A lot of papers reported that the larger size of the dentulous area creates more error than the smaller size of the dentulous area. So why was that? Because the intraoral scanner capture the same pattern of the picture on the dentulous side. So diagonal error from the scan model can be occur after using the intraoral scanner. So now Andreessen and colleagues paper reported that between two implants, scanning between two implants, it can cause angular error from the diagonal error. So, and in this study, it seems that the relationship between inter-implant distance seem not have the effect on the angular error. So this leads to the objective of this study that to compare the angular error generated by intraoral scanner between 7 and 14 millimeters inter-implant distances, and also to compare the accuracy of each intraoral scanners in the angular error aspect. Next part is the research methodology. First of all, we have to prepare the digital model. The digital model has been prepared in the mesh mixer software, making a hole, and then print it out, and then fix the scan bodies in those holes. And after fix that, confirm the range of inter-implant distance that it is going to be 7 millimeters and 14 millimeters inter-implant distance by using digital vernier clipper. And after that, the model has been prepared reference data in STL file by using desktop scanner. And after that, the test data has been prepared by using an intraoral scanners, 10 scans per each models and also each scanner. We have two scanners in this study. First one is 3 and another one is CREC Omnicam. After that, we have test data and reference data. Two data has been superimposed by using two steps of superimposition. First one is pre-alignment or 3-point alignment. And after that, local best fit alignment to confirm that it is completely superimposed by using an ICP or closed or iterative closed point algorithm. This process has been performed in the GOM Inspect software, which is a reverse engineering software. Now we have two intraoral scanner, right? The first one is the 303, and the second one is CREC Omnicam. The angular has been analyzed by using the same program, the same software, which is the GUM inspect software. And after that, after we have the value of the angular error, the statistical analysis has been performed in the SPSS by using Mann-Whitney U test of each group. And this is the example of the angular error measurement. As you can see that the cylinder of each scan body has been generated by using a Gaussian fitting element. After generated the cylinder, we have the axis of each implant. This axis is compared to calculate the angular error between reference data and the test data. Next part is the result and discussion. You can see from the table and the chart here that according to result, CR refers to CREG omnicam. As you can see that CR have the statistical difference between 7 and 14 millimeters, which 14 millimeters have more errors than the 7 millimeters, while TR scanner or 3 scanner have no significant difference between two inter-implant distance. And if compared between two intraoral scanner in the vertical column here, you can see that there was no significant difference between two intraoral scanner in both inter-implant distance. And from the line here is the 0.4 degrees, which I have presented that 0.4 degree is the maximal limit of the passive fit. So further than 0.4 degree is considered as misfit, right? From the total data, it was approximately 40% that of the data that exceed 0.4 degrees. So it was a chance that approximately 40% that have angular error from using intraoral scanner. So why was that? Now, first of all, CREG OmniCam was a confocal technology, and the Trios 3 was a confocal technology principle, and the active triangulation was CREG OmniCam was an active triangulation. So the difference between these two technologies is first that the confocal technology requires a larger receiver, while the CREG OmniCam or active triangulation require a smaller receiver. Because of the size of the receiver, the CREG OmniCam have better accuracy, have better accessibility, but while the Trios 3 have poorer accessibility. So in smaller area, in 7 millimeters here, CREG OmniCam have less angular error when compared to the Trios 3. And also according to the size of the receiver, the larger edentulous area or 14 millimeters, Trios 3 have less angular error when compared to the CREG OmniCam. So the Trios 3 have less stitching error in larger edentulous area, while the CREG OmniCam have more stitching error when compared to the another scanner in the larger edentulous area. So since this study is an in vitro study, and under the limitation of this study, it can be concluded that larger edentulous area creates more angular error of the scan data, and it was approximately 40% chance of getting angular error. And if compared to two technologies, the confocal technology provide superior accuracy than the active triangulation in larger edentulous sites. And these are all the references that are used in this project. Now, thank you for the RSU conference that having me here. And if you have any questions, please feel free to ask. Thank you.
Thank you so much for your good presentations and nice slides. This is very useful for all the audience right now because most of us are very into implant right now, and the way of using impressions and or either intraoral scanner are becoming questions, right? So there's some questions.
Yep.
Are there any questions from the audiences? I still cannot see anything in the chat, but I'm looking forward to it. Well, from this, after you do this,
Yeah.
it seems like both of them are exceeding the um, the number of the deviation that you concern, right?
Yes, according to the Anderson colleagues paper. Yes.
Yes, it's 0.4 degrees. So would you please tell me from your result that how you could bring it to apply to your clinical situations?
All right. So as I have talked about the differences between two technologies, the 303 is a confocal technological principle, and the other one is the active triangulation. So because the size of the larger receiver, it is beneficial in the large edentulous size. So I am going to suggest that if we are going to scan the larger edentulous size, maybe we have to choose whatever scanner that is a confocal technological principle. And smaller size of the edentulous area, smaller size of the receiver, for example, like CREC on the cam in this study, it is more proper use in the single unit abutment or single unit implant or a single crown, something like that, in smaller area. In larger area, it's going to be inferior than the larger receiver size.
You mean larger edentulous area? How large?
So now, according to this study, 7 millimeters is to single implant crown, and the other one is 14 millimeters, which is 3-unit bridge. So because of the size of the receiver, and it causes a poorer accessibility. So in only one single crown, I'm going to recommend that the smaller receiver is more proper than the larger receiver, which is a 303 in this study. But however, according to the value of this study, it's not that significant difference, because in 7 millimeters was 0.39, and the other one is 0.55, which does not exceed the 0.4 degrees. So it can be used in single crown anyway, in smaller size.
Can I conclude that actually the intraoral scanner is more proper than impressions when we used to scan for single implants? Is that correct or not?
So if in a single implant, it had another study that talked about comparing between materials, conventional impression and intraoral scanner. Is not that much difference between using ideal materials of conventional impression and intraoral scanner. The ideal material include that it's the PVS, something like that, silicone. It's not much different between using the intraoral scanner and silicone in single crown impression.
So from what I heard, it's mean like actually the old way of using impressions still superior to the intraoral scanner at both single implants and multi-implants. Is that right?
Actually, in single crown, some study have reported that it's superior by using intraoral scanner than conventional scanner, conventional impression. But
Okay.
some study also have that it quite the same by using the intraoral scanner and conventional impression. So I think it can be used in other way, in any way, in intraoral scanner and also conventional impression. if it is single crowd. So if multiple unit, maybe we have to consider using other technique that which have more accuracy, something like that. So in single crowd, for my opinion, it's similar.
Mm-hmm. So from your experience, which one can you tell us about advantage of using conventional way? I mean, what's the pro and con between these two techniques? Like for example, the money you have to invest for intraoral scanners and
Yes, of
everything.
course.
Yes, I'm not sure if for intraoral scanner when we scan, we can use the information directly to the lab, right? Or you have to put it in the other machine before to transfer
You mean that
straight away.
if we're using intraoral scanner, we have to transfer to the how do we transfer to the lab, something like that?
Yes.
Actually, in the 303, now in each intraoral scanner actually have a software that link to the lab. But however, we can, if the software didn't link to the lab, we can also export that and send to the lab by using STL file too. So it can be both way, link to the lab directly or send it by user, something like that. And for the conventional impression, most of the lab that doing implant right now, for the conventional impression, it was just like impression and then take the cast to the lab, and then the master model is going to be scanned in the desktop scanner too. And then after that, decide by using a desktop scanner. So most of the labs doing something like that right now. I think you have some questions from the audience.
Yes, there's question from the audience. So
First one, according to your study.
according to your study, which one you suggest to select for both small and large edentulous area if we have to select only one scanner? I think you already answered.
Only one scanner.
Mm-hmm.
So for the small edentulous area, according to this study, it can be selected both intraoral scanner. So I cannot actually choose which one, but according to the ease of use and more open system, I'm gonna choose 3 or 3 from my opinion. And for the larger edentulous size, I'm gonna choose larger receiver, which is a 3 or 3 too. Yes, but however, in smaller edentulous area, we can choose anything. Something like that.
Well, the second questions, I think you already answered because they're just asking about 14 millimeter. We use 3 implants for individual crown. TR scanner used for these situations. So is 3R scanner can be used for the large edentulous arch. So you already answered, right?
Yeah.
That you. So one last questions because we have limited time. Because you do in the lab is in vitro, not in vivo, and even in vitro, the results show that it quite exceeds the acceptable limit. Do you think the results in vivo will be different or not, or worse?
So because the factor of the that affect the accuracy of intraoral scanner is a lot. I'm going to show this slide here, because there are a lot of factors that affect the accuracy of intraoral scanner. In vitro study have removed some of the factor. For example, like moisture here, the amount of keratinized tissue, operate something like luminance and light, something like that. So, and also the patient movement here. So if there are more factor in the clinical situation, the accuracy in terms of angle deviation or angular error is going, it tend to be increased if we have to if we put this factor in. So however, further study have to be performed anyway. But this is my hypothesis that if we put more factors in, it's going to be more error in the value.
Okay, thank you so much for all the answers and your presentations. So we're gonna go to the next presenter.